Now let's talk about a series. A series is the indicated sum of the terms of a sequence. So here are some examples. We have the sequence 1, 2, 3, 4. The series of that would be 1 plus 2 plus 3 plus 4. We're just adding those numbers together. If the sequence was 2, 4, 6, 8, the series would be 2 plus 4 plus 6 plus 8. If any of these were negative, we would subtract whatever the negative number is. But since here they're all positive, we're just adding them. A partial sum, which would be indicated by big S sub n, is the sum of a specified number of terms of a sequence. So we're going to have all these terms of a sequence. Maybe we only want to get to the fifth term in that sequence. So our partial sum would only add up the first 5 terms of the sequence. A series can also be represented by using summation notation, which uses the Greek letter sigma. This letter is sigma in the Greek alphabet, to denote the sum of a sequence defined by a rule as shown here. So we've got sigma, so that's telling me we're using a sum. The sum of the first 5 terms from term 1 to term 5, where here's our rule 2k. Now in this situation, k is the term placement. If we were talking about a sequence, that's what n was. Here, k is your place value in the sum. So here, if k was 1, 2 times 1 is 2. Then if k is 2, 2 times 2 is 4. With a k value of 3, 2 times 3 is 6. With a k value of 4, 2 times 4 is 8. With a k value of 5, 2 times 5 is 10. And this summation is telling us we need to add all of these terms together. So our final answer in this case would be 30 because we added every single thing together. So let's practice this. We need the sum of the 3rd through 6th terms of 1 over 2 to the k. So here, the first k value that we're going to use is indicated by this bottom number. K is 3. And we need everything between 3 and 6. So we're going to use 3, 4, 5, and 6. So we need 1 over 2 to the 3rd, plus 1 over 2 to the 4th, plus 1 over 2 to the 5th, plus 1 over 2 to the 6th. We're stopping at 6 because this number on top is a 6. From here, we could go to the calculator and figure out what each of these is. Or if you know your exponent rules, 2 cubed is 8, so we have 1 over 8, plus 1 over 16, 2 to the 4th is 16, plus 1 over 32, plus 1 over 64. Now I'm going to go to the calculator and calculate this sum. And making sure it's in a fraction, I end up with 15 over 64. This could also be done by hand if you have common denominators, but we've got a calculator, so we're going to use it. In number 2, we're looking at terms 1 through 4, and the expression is 10 minus k squared. So we've got 10 minus 1 squared, plus 10 minus 2 squared, plus 10 minus 3 squared, plus 10 minus 4 squared. We're stopping at 4 because that top number there was 4. 1 squared is 1, 10 minus 1 is 9, 10 minus 4 is 6, 10 minus 9 is 1, and 10 minus 16 is negative 6. So we have 9 plus 6 plus 1 minus 6, which comes out to a total of 10. Now we've got the sum of our terms from 1 through 4 of the expression 2k minus 1. So we've got 2 times 1 minus 1, plus 2 times 2 minus 1, plus 2 times 3 minus 1, plus 2 times 4 minus 1. 2 times 1 is 2, minus 1 is 1. 2 times 2 is 4, minus 1 is 3. 6 minus 1 is 5. 8 minus 1 is 7. Adding these up, we get a total of 16.